Okay, what's the difference? If you punch this in on your calculator, you get a -4. You punch this one in, you get a +4. The difference is the parentheses. The parentheses are a big deal. If you have a -2 squared in parentheses, that means you have a -2 times a -2. That means you're squaring the 2 and the negative. A negative times a negative. That's how come you get a +4. If you don't put it in parentheses, that means you're only squaring the 2. So you're going to have a -2 times 2, and that's going to be -4. On the test, your quadratic equation, this part right here, the square root of b squared minus 4ac, this is where you will mess up. Audrey, if you have a b squared, if your b, let's say your b is -2, if you type this in, a -2 squared, without the parentheses, you will miss it. When you're doing the quadratic formula, you have got to put this in parentheses. Your b, the most important part, if you're just plugging in the calculator, your b has got to be in parentheses or you're going to miss it. Lydia? Number 2. Okay, which one of these are going to be imaginary? If you square root, this is the same as x is the square root of -16. That is imaginary. Anytime you've got a negative under a square root, that's imaginary. You cannot times an even amount and end up with a negative number. So this one, -2 times -4, that's the square root of a +8. You're safe. This is the square root of a -8. That's imaginary. This even amount, positive answer, you're safe. I times I is a -1. So this is actually a +6. You're safe. Because you have an odd amount, that's going to be imaginary. That's imaginary. 57, I got an odd amount, that's imaginary. So you should have circled how many? 1, 2, 3, 4, 5? Okay, multiply each one by 2i. If you multiply 1 by 2i, that gives you 2i. 2i multiplied by 2i is 4, and I times I is a -1, so it's got to be a -4. -4 times 2i is going to be a -8i. No, because you do a -4 times 2, that's -8, but there's only one I. If there's 2 i's, that's a negative. So this next one, a -8i times 2i, a -8 times 2 is a -16, but I times I is a -1, so it's going to make that +16. 16 times 2i. 16 times 2 is 32i. 32i times 2i is going to be a -64. -64 times 2i, -128i. -128i times 2i, it's going to be a +256. Times 2i, it's going to be 512i. So they kind of alternate. Real, imaginary, real, imaginary, real, imaginary, real. But look, your reals go from positive to negative to positive to negative, and your imaginaries do the same. This imaginary is positive, this imaginary is negative, this imaginary is positive. So multiplying by 3i, 1 times 3i will be 3i. 3i times 3i will be 9. And I times I is a -1, so it's going to be -9. -9 times 3i is going to be a -27i. -27i times 3i A negative 27 times 3 is a negative 81. I times I is a negative. So negative times negative, that's going to be positive 81. So 81 times 3i is going to be 243i. 243i times 3i. 243 times 3. Now the numbers are starting to get kind of big. 729. But it's going to be negative 729. Negative 729 times 3 imaginaries. Negative 2,187 imaginaries times 3i is going to be 6,561. Oh, is it going to be positive or negative? It's going to be positive because a negative times that's going to be negative, but I times I is negative. And then the last one, 19,683i. Then we have got 4 problems with imaginaries. This first problem is just a plus. So I'm going to add my reals together. A negative 8 plus negative 8, negative 16. And add your imaginaries together. A negative 4 plus 6 is going to be 2 imaginaries. That's it. Negative 16 reals plus 2 imaginaries. This one, I got to multiply both of these by 4. 4 times negative 8 is negative 32. 4 times negative 6i, that's going to be negative 24i. 3i times 3i. 3 times 3 is 9, but I times I is a negative 1. So now combine your reals, a negative 32 and a negative 9. Negative 41 reals, negative 24 imaginaries. So did you get the negative 32? But this right here, Dakota, 3 times 3 is going to be 9. But I times I is a negative 1. So it's going to be negative 9. Okay, now, this one you got to times. So you need to multiply the 2 to the 8. That's 16. 2 to the 7 imaginaries is going to become 14 imaginaries. A negative 3 imaginaries to the 8 is going to be negative 24 imaginaries. Negative 3 imaginaries to the 7 imaginaries is going to be negative 21 imaginaries squared. But an imaginary and an imaginary, this guy right here, I squared is the same as a negative 1. Negative 1 times negative 21. Positive 21. So this positive 21 is going to match up with the 16. So now that is going to give us a total of, is that 37? 37 reals. And your imaginaries, you got 14 and a minus 24. Minus 10 imaginaries. Okay, the last one. I need to multiply the negative 3 only to the negative 8 and the 5 imaginaries. So negative 3 to the negative 8 is positive 24. Negative 3 to the 5 imaginaries is negative 15 imaginaries. Now this one, you got to take the negative with it. The negative 2 to the negative 8 is going to give you a positive 16. The negative 2 to the negative 1, I is going to be positive 2 imaginaries. So total up your reals. What's 16 and 24?
That is 40.
And then total up your imaginaries. What's negative 15 and 2?
Minus 17.
Minus 13?
17. What do you do? 13. Oh, no, never mind. 13.
Is it 13?
It is 13.
Okay. If I give you this function that matches up with this graph, and I ask you, Copeland, you guys pay attention. When does this function give you a 3? Here's what I'm asking you. When is it going to cross at 3? So you come up to 3 and you draw a line and you got to figure out when it crosses. And it is only going to cross once. It's going to cross at 3. So x is 3. And it's only, if there's only one answer, that means it's crossing at the vertex, because that's the only spot on the parabola where it's going to cross once. Look at this one. When is it going to cross at level 1? So you come up 1, and this entire level 1 goes forever left and forever right, but it's going to cross it twice. Yeah, the answer is just 3, because it crosses at level 3. I have to go over 3 to get up 3. Now here's my question right here. How far do you have to go over to go up 1? I've got to go over 2, 2 and 4. So x has got to be 2 or 4. This question, when is this function going to equal a negative 5? So come down here to negative 5, and it equals x is going to be 1 or 5. So if you're looking at a picture, it's easy. But now the next two questions, when is this function going to give you a 2? So come up to level 2. What do you know about these numbers? There's some kind of decimal. They're not whole numbers, because it happens somewhere between 2 and 3 and somewhere between 3 and 4. Some decimal. Daxton. If it's some decimal, you have to use the quadratic formula. What about this? When is it going to cross at 4? It never will in the reals, but it will in the imaginaries. So all I want you to understand is, if it's between two numbers, it's going to be some decimal. We're going to use quadratic formula. If it's not even on the parabola, it's going to be imaginary. Okay, look, these are the ones you get misunderstood on. There are 4 functions right here. 2 of these 4 are going to be very, very easy to factor. Yeah. So Tanner, the only way you can figure out which ones are going to be easy to factor, let's get everything on the same side. So let's plus 9b here, and let's plus 9b here. So you're going to have 10b squared plus 9 equals 0. Just leave that. Leave that there. Let's go to the next one. Let's move these over here, and let's move these over here. So let's plus 5r squared to this side, and let's plus 5r squared to this side. So you got, this is r squared. But if I plus 30 here, I cannot, how come I cannot add 30 to a negative 11r? So I'm just going to go negative 11r plus 30. And then on this side I got 0. Okay, let's do the same to this third one. Let's move this guy over here. So let's minus x squared, and let's minus x squared. So that zeroes out. And then this is going to be x squared minus 7x plus 10. And then let's do the same here, and then let's see if we can figure out the answer. So let's minus 2n minus 2n And let's plus 5 on this side and plus 5 there. So if you do that, you're going to have 12n squared plus 12 and 0. So that's your first move. The only way you can determine is if you get everything on the same side. Now, factoring is if you can do this, your little template. So let's see which of these four are going to be a piece of cake to factor. This guy right here will be easy to factor because can you find something that multiplies and gives you 30 and adds and gives you a negative 11? It's going to be 6 and 5. Are they both positive, both negative? You got one of each. They both have to be negative. So if you can multiply and get C, add and get B, this is going to be super easy. So now look at this. It's going to be R minus 6 times R minus 5 equals 0. So what does R have to be? R has to be a positive 6 or a positive 5. How come they have to be positive 6 and positive 5? There we go. So if your answers are whole numbers or opposites, if they're negatives, at least Lexus, that means, look, if you get easy answers like this, that means it's crossing on, it's like this, it's crossing on numbers. It's imaginary or it's some junky decimal. So Lexus, let's factor this one. What's going to times and give you 10 but add and give you negative 7? It's going to be a negative 2 and negative 5. Negative 2 times negative 5 is going to be positive 10. Negative 2 plus negative 5 is negative 7. So it's going to be x minus 2 times x minus 5. So x is 2 or 5. Now, Lily, look at these. How come these are not easy to factor? They're missing a piece. And look, what is A? Look what A is. What's A? A is a 10 and A is a 12. What's A on these? A is 1 and A is... If A is 1, they're a lot more simple. So because these A's are 10 and 12, these, the only way you want to do is quadratic formula. The quadratic formula, probably when A is anything bigger than 1. So if A is going to be 10, Brian. So this guy, if you move this over, minus 6x, you got 9x squared minus 2x plus 3 is 0. Now, Shalise, do you want to try and factor this, or would you rather use quadratic formula? Quadratic formula. Because, Jace, look, A is 9. If A is any number bigger than 1, we're going to use quadratic formula. If to use the quadratic formula, you just look off of A. Because look at these, Hunter. The ones that we factored, your A was 1. So all you had to do is find two numbers that times give you 30, add and give you 11. And this one right here, your A is 1, so you don't even need to worry about the A, you're just looking at the B and C. What's going to times to give you 10, but add and give you 7. Now, if, Tanner, look, if this A is 9, you got too many options because you have to get 9x squared. So you can't just put x and x. Maybe one of them's going to be a 1 and one of them's going to be a 9. Or one of them could be a 3x and a 3x. Because you got to times these to get 9. But now you got to figure out what's going to times give you 3, add and give you negative 2. So that's going to be too messy. It's going to be best just to do the quadratic formula. So the quadratic formula, Emma, you use if a is anything bigger than 1. Let's look at this one. I'm going to minus 5x minus 5. Minus 5x on this side of minus 5. So you got 12x squared plus 10x's minus 5 is 0. You want to try and factor that or quadratic formula? This would be plus 5. Plus 5 right there. This one, these two right here, you want to use the quadratic formula. Look at this one. Minus v squared plus 3v plus 3v. So I'm going to have v squared plus, do we have 9 v's? Plus 18 is 0. So Jordan, what's going to times? Now look, my v is, I got 1. So what's going to times give you 18, add and give you 9? So this we're going to do x plus 3 and x plus 6. It's going to be easy to factor. If your a is 1, the chances are it's going to be pretty easy to factor. This one right here is going to be x squared plus 5x minus 1 plus 6 is 1. 0. Does there exist something that times gives you 6, add and gives you 5? Dakota? Dutson? What times this gives you 6, add and gives you 5? It's got times give you 6, add and give you 5. So look, this is going to be easy to factor. But these top two, you got to use quadratic formula. So go ahead, plug them in, find ABC, plug them into the quadratic formula, solve them.